Good morning. So if you're quarantined or sick at home and you missed today's notes in class, hopefully this will help you understand what we're doing with inequalities. So we've been working on equations. Equations is when we have an equal sign, right? When one side is equal to another. Now we're going to do the opposite of that. An inequality means that the two sides are not equal. Well, when they're not equal, they are either going to be not equal to, greater than, less than, greater than or equal to, less than or equal to. So an inequality is a mathematical sentence that compares expressions containing one of these symbols. So if we look at this one right here, this is read t is not equal to 4. And the second one is t is greater than 4. Well, if t is greater than 4, t can't equal 4, right? That's why they're inequalities. So the two sides are going to equal something different. All right, next definition. The solution of the inequality is any number that makes the inequality true. Now, you're going to see when we solve for inequalities, there can be multiple. There can be an infinite number of solutions. So this is not going to be like equations where we had x equals 8 or x equals 2.5. It's going to look different than that. A solution set. Now I just said that you're going to have multiple solutions. The solution set is the set of all solutions in an inequality. So if we look at this one, h is greater than or equal to -2. Well, what numbers could be greater than or equal to -2? Well, -2 could be greater than or equal to -2. 1 is greater than or equal to -2. 15 is greater than or equal to -2. 100 is greater than or equal to -2. And I could keep going on and on and on forever and ever and ever. Graphing an inequality shows all of the solutions that satisfy the inequality. All right, so we are going to look at x is less than or equal to 3. And I am going to follow steps 1 through 4 down here at the bottom. So step number 1 says find the starting point and put a circle there. Well, the starting point is the solution to the inequality. So it says x is less than or equal to 3. So I'm going to find the number 3 on my number line, and I'm going to put a circle at the number 3. Number 2, decide which direction the arrow will point. Well, notice how the arrow in the less than is pointing to the left. So we are going to darken the arrow pointing to the left. That is the direction that our arrow is going to get darkened. Number 3, decide if your circle is open or closed. So an open circle is only when you have the signs less than or greater than. A closed circle is for less than or equal to and greater than or equal to. And I'll explain to you in just a second why. So since this is less than or equal to, it's going to be a closed circle. So we're going to go back up to the number line to the number 3. Closing the circle means that I'm going to fill in that circle at the number 3. Now what that means is that 3 is a solution for x. So this number is less than or equal to 3. Well, 3 is less than or equal to 3, right? 3 is less than or equal to 3. Yep. 2 is less than or equal to 3. So notice that 2 is a possible solution. -4. -4 is less than or equal to 3. It doesn't have to be both. It has to be one or the other. -4 is less than or equal to 3. True. -9. -9 is less than or equal to 3. True. So the reason that we darken the arrow to the left is to show that every number 3 and less could all be solutions for that inequality. All right, we're going to try C is greater than -1. Step 1, put a circle at the solution. Step 2, decide which direction the arrow is going to point. The easiest way, I think, to decide which way the arrow is going to point is look at the arrow of greater than. See how the arrow of greater than is pointing to the right? So I'm going to find the arrow on my number line that matches, that's pointing the same direction. So that's going to point to the right. So all of these numbers are solutions for C. Now this one says C is greater than -1, so we're going to leave the circle open, because is -1 greater than -1? No. So -1 cannot be a solution. -1 is not greater than itself. Is 0 greater than -1? Yes. Is 8 greater than -1? Yes. So notice that 0 and 8 are both possible solutions for C. Let's try M is less than -5. Step 1, put a circle at put a circle at -5 on the number line. Decide which direction your arrow is going to go. So if you look at the less than sign, that's the arrow pointing to the left. So this arrow is going to get darkened, and we're also going to darken the line, showing that all of these numbers are possible solutions for M. This is going to remain an open circle. We're not going to fill it in because the solution or the inequality is less than. So if it's M is less than -5, is it true that -5 is less than -5? No. A number cannot be less than itself. So that's why that's why the circle is open. That's showing that -5 is not a possible solution for M. But if we look at the numbers to the left of that, let's just pick a number, -7. Is -7 less than -5? Yes. All of the numbers to the left of -5 are possible solutions for M. Now, why in the world are we graphing inequalities? As always, to solve problems. AJ has to get higher than a 90 on his next math test in order to keep his B in class. What inequality would we write if he has to get higher? So I'm going to use T for test. The test has to get higher. Would it be greater than or equal to? Or would it be greater than? Can he get a 90? Is 90 higher than a 90? He has to get higher. Oh, if he has to get higher than a 90, he has to get at least a 91. So it cannot be equal to 90. His score has to be greater than 90. So that inequality would read T is greater than 90. What if we change the wording and it said, what if it says he has to get at least a 90 on his test? He has to get at least a 90. His score could be greater than 90, or his score could be equal to 90. So that inequality would be T is greater than or equal to 90. Here's just a little key for you for all of the different symbols. We've got less than, greater than, less than or equal to, and greater than or equal to. And below that are some common words that you're going to see when you are reading through the word problems. All right, let me know if you have any questions.